This section is going to look at how to configure OSPF. So I'm going to pick up 2901, this router. This one is router 1. Then 2901, then router 2, router 3, 01. So we're going to set up one of the topology. And with that, we can actually connect switch. You see, yeah. So you're going to connect here, PC to switch, and then switch to router. Again, PC to switch, and then switch to router. So in this scenario, we have 3 different routers, and we have PC1 and PC2. So in here, we're going to assign some subnet. Let's say 192.168.10.0/24. So I'm just assigning this subnet. This is we can assign any other subnet, but for this example, I'm just using this particular IP address subnet. Now, router each interface we need to have different subnet. This one will be 11.1.1.0/24. This one 12.1.1.0/24. This side 192.168.20.0/24. In this way. Now, from each of the subnet, we need to have IP address. So from this one, I'm going to put 192.168.10.1. Then gig 01, it will be 10.10. So each of the interface, you need to have IP address. This one will be 11.1.1.1. Then gig 00 will be 11.1.1.2. This one will be 12.1.1.2. And this one will be 12.1.1.3. Then this side gig 00 will be 192.168.20.10/24. Okay. /24 is not required. This is just the IP. And for this PC, IP address will be 192.168.20.1. So this is the topology we have set up. Okay. So you have all this interface. You can see different subnet, and from each subnet, we have specific IP address. From this subnet, let's say 20.1 is this PC, and 20.10 is this interface. Now, so basically, part of the configuration. So each of the interface we need to configure IP address. Let's say PC, we need to assign this IP address. Router, each interface we have to configure, right? And after that, once you configure everything, after that we're going to apply OSPF routing over there. So at first, I'm going to configure these 3 routers. Okay, then we configure the PC. I'll go to my first router. CLI. So when you say, would you like to enter initial configuration dialog, just say no. And then in this way, you start to configure new router. And then we say enable config T. Hostname will be R1. Then router 1, we have 2 interface. So interface gig 0/1, which is this one. I'm saying IP address 192.168.10.10. Mask will be 255.255.255.0 and say no shard. So no shard is very important because in this way that particular interface will be up. And now I'm going to configure this IP address, say interface gig 0/0, IP address 11.1.1.1, mask 255.255.255.0 and say no shard. After that, this is router 1. Then I'll go to router 2. So router 2, each of the interface we need to configure. So I'll put the topology slightly bit this side. So router 2, I'll say in here is saying, would you like to enter in the initial configuration dialog? Just say no. Enable config T. Host name will be R2. So we change the router name and then interface configurations. Interface gig 0/0, IP address 11.1.1.2, then mask 255.255.255.0. Say no shard. Then interface gig 0/1. This is the second interface, which is this one. It will be IP address will be 12.1.1.2 and then 255.255.255.0. Say no shard. So same process. All the interface configurations will be same. Now I'm going to move to router 3. Yeah. So router 3, I'll say again no to this dialog and say enable config T. Hostname will be R3. Then interface gig 0/1. IP address will be so interface gig 0/1 IP address will be 12.1.1.3. So it will be 12.1.1.3 mask 255.255.255.0 and say no shard. Then interface gig 0/0 IP address will be 192.168.20.10. Mask will be 255.255.255.0 and say no shard. So this one will be this interface we just configured in here. In this way, now you can see all the interface before they were down and was red color. Now they are actually green. This one is kind of negotiating at the moment. Now all the IP address configurations is done. So if we'd like to verify, we can say show IP interface brief. With this command, we can verify and see whether all the interface configured properly or not. and the interface they have the correct IP address or not. We can actually check all these stuffs. After that, we'll configure the PC. So I'll go to my PC1 desktop IP configuration. We put the IP address 192.168.10.1, then subnet mask, default gateway 192.168.10.10. So default gateway will be always your router internal IP address. That will be your default gateway. I'll close this one. I'll go to PC2 desktop IP configurations, and I put 192.168.20.10, and then we put subnet mask, 192.168.20.1, and subnet mask, and gateway will be 192.168.20.10. And close this one. In this way, for each of the interface, we have the IP address. Now, once we configure IP address, then we can do our testing. So from this PC, if I go to command prompt, now I would like to ping in same subnet. Then I'm going to ping different subnet and see is working or not. So if I ping 192.168.10.10, it's pinging, right? It's replying because now we are in same subnet. But if you'd like to ping something in another subnet, let's say if I ping 11.1.1.2, it will not work because we do not have any routing. See request timed out. So after that, even if I want to ping that 20.1, ping 192.168.20.1, that's my PC2, it will not work. It's a destination host unreachable because it doesn't have any routing. So how to enable routing? So that's where we're going to configure OSPF. Let's say I'll go to at first my router 1 and we'll exit from interface. We need to be in config mode and say router OSPF 1. I can put 1, 5 or 10, anything. That is just a process. Hit enter and say router ID 1.1.1.1. So this is any configurable value, but to refer to router 1, I just simply put 1.1.1.1, and this format is must. We have to use this format. After that, we define the router ID. After that, we add the connected subnet. So network 192.168.10.0 and then 0.0.0.255 space area 0. That's how we add this subnet. After that, we can add another subnet. Say network 11.1.1.0, then 0.0.0.255 area 0. In this way, we have this two subnet. After that, so this is we configure router 1, but the process will be same, right? I'll go to router 2 and say exit from there, router OSPF 1, router ID 2.2.2.2. That's my router 2. That's why I just put like that. Network 11.1.1.0, wildcat mask 0.0.0.255, area 0. So in this way, I have added 11. Now look at that. Already this router make neighbor relationship with other router 1. You can see neighbor adjacency came up. their loading is loading to full, loading done. That means they are in full state. And then we're going to add the other one, which is network, then 12.1.1.0, then 0.0.0.255, area 0. So with my router 2, this connected subnet we have added in here. Now I'll go to my router 3. So router 3, what I have, 12.1.1.0 and 192.168.20.0. Basically, these two subnet we need to add inside the OSPF. 150 router OSPF 1, router ID 3.3.3.3, network 12.1.1.0, then 0.0.0.255, area 0, and network 192.168.20.0, then 0.0.0.255, area 0. Right? So these two subnets, see the other subnet, 12.1.1.0 subnet already synchronized with router 2 or make neighbor relationship. And now we add the 20.0 network as well. Now pretty much all the way we have routing, because OSPF knows about 2 subnet, this one knows about this 2 subnet, this one knows about this 2 subnet. Now we can check with some verification command. So this is router 3. I can check from any of the routers. So I'll go to router 1. So let's check everything from router 1. So show IP OSPF, show IP OSPF neighbor. We can see the neighbor, which is 2.2.2.2 came up. Show IP OSPF database. We can see inside the database we'll have all these information. See, we have router ID, process ID, area 0. We have router 1, router 2, router 3. All these router we can see. So it has a router link state and network link state. These informations we have. So show IP protocol. We can see this is OSPF protocol running in router 1. Router ID is this one. Maximum path it can add 4. And we have the routing for those network. And this is the gateway, means all router ID info. See 110, this is the administrative distance. Show IP OSPF interface. See hello and date interval. This command is important. Show IP OSPF interface. With that we can see the link informations. But most importantly, we can see the hello and date interval. Hello is 10 seconds and date 40 seconds. So sometimes let's say another router is not making neighbor relationship. So maybe someone configured different hello timer in another router. That could cause the problem in the network. And if you do simply show run, you can pretty much check what we have configured. Like you configure router OSPF 1, you configure router ID this one, then you have added this network. Sometimes let's say if whether something is not working, then you troubleshoot and see whether you have added that particular subnet properly or not. So all this show command you can use to find out the OSPF informations. We also can say show IP route OSPF. So it's showing me that I have routing to 12.1.1.0 network via this IP address, or I have routing to that 20.0 network, and 110 is the administrative distance, and this 3 is the cost, right? We talk about OSPF cost. So to reach 12.1.1.0 network, cost is 2. To reach 20.0 network, cost will be 3. So we can see that all the way we have routing from router 1 to all the way this side. After that, if I'd like to ping, say ping 192.168.20.1, now it should be working fine. You see, it's working. It's sending packets. First one failed, but if you do it again, you can see that you send 4 packets, you receive 4 packets, lost 0. So once you enable the routing, then pretty much from source to destinations, it will communicate. So in this way, pretty much you can configure OSPF routing protocol.
I hope this information was informative for you, and thank you for watching.